Welcome to qnawire.
We want to know what is going to be the pKa from the titration of acetic acid. So the titration curve is going to look something like this. Whenever we're adding more of the volume of sodium hydroxide, we're going to see the increase of the pH. So in the case of acetic acid, for CH3COOH, what we're going to see is that the pKa would be equal to 4.78, 4.76. Okay. Now, what we're going to do is that when you see the curve, we're going to have the equivalence point. This is when we have added the same amount of sodium hydroxide, and at the half equivalence point, we're going to see that the pH is equal to the pKa. So with the graph that you're going to have of pH versus volume of sodium hydroxide, you're going to find the equivalence point. You're going to go down here and look at the volume at equivalence, and then look at what is going to be the pH at the volume of the half equivalence point. You're going to simply divide that volume by half, and the point over here is going to be your pKa. Now, just as a reminder of why that is going to be the case, the reaction that we're going to have at the half equivalence point is going to be the following. When we reach the half equivalence point, the amount that we have added, the amount of mole that we had added of hydroxide is going to be equal to 1/2 of the initial amount that we get. So the change is going to be equal to minus 1/2 of the initial amount of mole. The amount of water generated, it doesn't matter because it's a condensed phase, and what we're going to get is that the amount of mole is going to be the same for the acid and its conjugate base. Since the amount of mole is going to be the same, the concentrations are going to be the same. So the concentration of CH3COOH is going to be equal to the concentration of CH3COO minus. That means that in our Henderson-Hasselbalch equation, the pH, which is equal to pKa, plus the logarithm of the concentration of the conjugate base divided by the concentration of the acid, is going to become pH equal pKa plus logarithm of 1. Both quantities are the same. The logarithm of 1 is equal to 0, so pH is equal to the pKa at the half equivalence point.